Hello and welcome to another episode of Everything Digital Health. I'm Marcus Bohr and I'm a GP in Yorkshire. I'm a self-taught software developer, clinical informatician and clinical safety officer. I do a lot of work in open source and this is my YouTube channel where we talk about digital health topics. I hope you enjoyed my last episode, which was about vibe engineering and some of the possibilities that recent developments in LLM-based coding might present to clinicians who code. And today I'm going to talk about APIs or application programming interfaces. And I apologize if some of my subject matter is kind of jumping around a little bit. I'm sort of finding my feet with how to do these videos, and also there's a lot of kind of backstory that I want to get out, and sometimes it's not coming to me in a nice clear one after the other sort of order. But I still want to just get the videos out really in case they're any help to people. So what I will probably do in the future is I'll start to create some playlists that are more about, here's a playlist if you're interested in terminologies. Here's a playlist if you want to watch the interviews I do with figures from the health informatics world. And here's a playlist that you can watch if you want to learn to vibe code or vibe engineer and that sort of thing, clinicians who code track. There is already a playlist for Open Source is the Only Way for Medicine. And there's my recommended playlist of stuff that from elsewhere on YouTube that I really recommend people watch. For now, though, let's crack on and I'll talk to you about APIs. I think it's a really important thing to fully understand, because it's one of the areas where the rest of the tech world has essentially gone headfirst into APIs and has made it a staple part of the environment you're working in, and healthcare technology has not. That's why we're struggling to keep up with the pace of developments in the rest of the tech world, because we just haven't done the infrastructure work. So this is my presentation, and you'll notice that I actually did this presentation 11 years ago, and I don't actually think much has changed since I did this presentation 11 years ago. I was in the process at this time of sort of learning more about health technology and also learning to code myself. And I was looking at the two worlds and seeing how different they were, that like health technology existed in this very proprietary space where nobody made any infrastructural services for anybody else. And the only thing that you can buy is a vertically integrated full stack product. And it makes it impossible to compose these things together. Whereas in the real tech world, as I refer to it, you can get an API from one source and then connect it to an API from another source and build your special product in between those things. And I do come to that later on in this talk, so I'll crack on. But I called it making difficult things less difficult, because really, this is actually just the story of human progress. If you look at what we do in civilization, some of the things that would have been hard or even just plain impossible 100 years ago, 1,000 years ago, or 10,000 years ago have become completely kind of everyday things. So like, we solve a problem, you essentially commoditize it and make it so that people can now move on to the next hard problem rather than trying to solve the same problems again and again. We're not doing that in healthcare tech, and I can come up with dozens of examples of where we haven't taken single functions and wrapped them in a layer that makes them very easy so that you can just build your app on top of them. Let's, without patronizing people, I want to just sort of show how, water acquisition used to take a lot of time. You would go and collect rainwater or go to the river, and just to get water for your everyday needs, now we have an API for it, which is called a tap. I don't want you to think I'm being stupid. This is genuinely something that would have taken you like 3 hours a day 200 or 300 years ago. And now you don't think about water. And that means you're free to think about these other things. If we don't do this, then there is no progress. People just stagnate doing the same things day in, day out. And there's no freed up human time to come up with next innovations. And I think that explains a lot of why we are more or less stagnated in terms of some of the things that we want to do in healthcare technology. Putting aside the big shiny, there is always, you know, a hype thing every year. At the moment, it's AI. 5 years ago, it was RPA, and 10 years ago, it was big data. They come and they go, these hype cycles, and they give us the impression that we're actually making progress. But if you look at the average journey of a patient through the healthcare system, it's still totally fragmented, and part of the reason it's that fragmented is because of organisation-centric healthcare records, which mean that part of your data is in one hospital, some of your data is in the GP surgery, some of it's at the private physio. No one's got a joined-up view of you, and that is a digital failing. We still don't know how to build a patient-centric healthcare record. I'm not saying that an API would be the sole solution to that, but it's certainly part of the solution. If you look at electricity, you know, when it was first invented, it was very hard to make any kind of electricity. This is sort of a hand-cranked static generation wheel or something. That's a turbine hall, I think, at Drax Power Station, where my dad used to work. And now we have an API for electricity. You know, we assume that electricity will be available to us. The fact that we don't have to make our own electricity makes it much easier to obtain, and you know, we just plug our laptop in, plug our washing machine in, and it just works. There's another aspect of APIs here on show, which is standardization. When you create a standard way of obtaining a service, you can make things easier to reuse. So for example, I'm showing you here a UK socket with a 3-pin plug. Everything you buy in the UK that's electrical will be able to plug into this. So there's no pain around the connection process. It's simply plug it in. The other things that are standardized, 50 hertz and 240 volts. That's very important. If there was no standardization of those parameters, then you wouldn't necessarily just be able to buy an appliance and know that it will work in your sockets. So it's an important thing for standardization when we create an API like this. In computing terms, you know, we've commoditized and sped up the computing availability so that it's very easy to get a very powerful computer without having to build it yourself or to have a look at the electronics yourself. You can get a computing device. And if we look at the web, you can do some very impressive things. And around the time I wrote this was, you know, that kind of web framework explosion of the sort of mid 2000s to the sort of mid 2010s, where everything was APIs and you could do all these incredible things. And that was simply because things like mapping, you know, was wrapped in an easy interface. So like, here we go. Twilio is a service that allows you to send like text messages or place calls programmatically. So you can write a program or a web service that will send a text to the patient or send a text to effect like a two-factor authentication. All the things that you use that send you a text are using one of these kind of services. But imagine if they had to build that themselves from scratch. Well, the challenge would be too big, and it would essentially, they would run out of money before they got anywhere. So it is really important to break down these services into sort of manageable commodity services that are provided by more than one provider, so that you're not in a monopoly situation either, and just put them out there. So the parallel in healthcare would be a web service that allows you to do EPS compliant prescriptions. At the moment, if you want to do that, there's an incredibly difficult and long-winded process to get approved to be able to create an EPS prescription on the spine, and it's a very long period of time whilst you're being accredited. It costs a lot of money. It's technically difficult. But if that was wrapped in a much easier layer, then you would be able to build a web service So say you're a new GP market entrant and you want to just make it so that you can do an EPS prescription, there should be an API that makes that a lot simpler. In compute and storage, we've got lots of options for getting a virtual machine, for example. If you want to get a server on the internet, then AWS or Azure or DigitalOcean, there's all these things out there and it's been commoditized to the extent that now there are layers and layers of simplicity on top of this commoditization. You don't even need to rent a whole server now. You can just have a runtime that will execute just a single script or something. And it will only cost you money when it's actually running, and then the rest of the time it's not costing you anything. These are iterations upon the compute and storage type thing. Standardization becomes simpler because, as an example, Amazon Web Services created one of their first services was simple storage, S3. I forget what the third S is for. Scalable simple storage, I think it might have been, SSS, hence Amazon S3. The API that you use to access that has become the standard now, pretty much across all of the other providers, I think with the exception of Microsoft because they have to do it special. But DigitalOcean, for example, have S3 compliant storage. So the fact that one mover, an early adopter, produced an API meant that others made an API compatible version that you can run on their system. So that's like the plug, the 3-pin plug, or the 50 Hertz standardization. We get a degree of commoditization. That means you can switch from one service to another service with relatively little friction. Where is that in healthcare? It ain't here. It's completely absent. Mapping, you'll be aware that it's very easy to get a map from Google Maps or a number of competitors now, and you can embed that in a website, for example. Would it be feasible to build a mapping service if you were building a website for, say, a restaurant, and they said, we'd like a little map in the bottom of the web page that tells you how to get here from anywhere? And you'd be like, well, it's a lot of work to do just for a restaurant website. But because the API already exists, it's relatively trivial to just add that in. And so that is an example of super commoditization of this stuff. Where is that in healthcare? It just doesn't exist. So these things that were difficult in the past get made easier, and that pushes it down into what I've called in the past a don't care layer. I don't need to care about certain technical implementation details. I haven't had to write that code from scratch. I can just get on and do it. And that means that I can actually work on the problem I'm trying to solve and make that easier. Push that down into a don't care layer. We're still stuck in healthcare tech with monolithic systems that claim that they can do everything everywhere. However, I can absolutely guarantee you they cannot possibly deliver a patient-centric healthcare record. And there's one very simple reason for that. They're purchased by organizations. A monolith system is purchased by an organization to do the work that organization needs it to do. The patient has not paid for it, and therefore the patient is not the customer. The patient will not get what they want. When an organization pays for a healthcare record system, quite reasonably, they pay only for their organization to have that system. It would be ridiculous for them to be paying for every organization to have that. So you'll never get joined up systems. Though you'll never get the same system everywhere. Not that we want the same system everywhere, but you will never get a completely joined up patient record because the records are all paid for by organizations. Organization-centric records are by definition fragmented. I think that's I've got some stuff I want to do and talk about in regard that in other episodes, so I'll leave that there. But long story short, we do need to break up the monoliths into different services that they do. One of those services being the persistence. Nobody, when you talk to them, disagrees about this. And I have had conversations, going back to the NHS X era, I used to have discussions with Hadley Beeman, who was an advisor to Matt Hancock, the then Health Secretary, who sprang up NHS X at the time, back when X things were cool. And I used to talk to Hadley about separating the application from the data. And now that phrase, separating the application from the data, has trickled up into all the talk that comes out of a lot of healthcare systems. But the problem is, no one's doing it. And also, no one knows how to do it. Because the way that current systems are built, they are a monolith. And that means that all of the application logic is intrinsically linked to the way it saves the data and the way it stores the data. You can't just separate those things without doing a lot of work to make them semantically interoperable. And we just don't have that. As an example of wrapping things in a simple API, clinical calculators. So there are several hundred, if not getting on into the thousands, of small clinical calculations that we use in healthcare. I'll switch out now to show you some of those on another website. So this is MD Calc. This is a website that has some calculations. It allows you to put in some information. This in this case, creatinine clearance, and you have to put in some data about the patient, and you'll get a response. And whilst this is all very well, there's no API. So this is exactly what needs to be behind an API, so that if I was building a clinical system, I could incorporate creatinine clearance into it automatically. Let's see, let's find one from, let's just see what the newest one is. SOFA score, I remember using that in ICU 20 years ago. Organ dysfunction in critically ill adults. Still, the problem here is that whilst this is better than trying to do it on a piece of paper, you're a clinician who's going to have to go and go to a website, fill this all in, and you get your score, and then you get to the result at the bottom. It'll tell you the SOFA score, and they've created soft interoperability. Is this idea of copying the results? I'm in favour of soft interoperability because it's better than nothing, but it's not. It's clearly not the same as this being integrated into a system. So this is just one example of many hundreds or if not thousands of clinical calculators that we use all the time. Where are the APIs for that? And there's a definitely like a business model behind this, providing clinical calculations, which are essentially a medical device, as a service. I mean, I've done it with digital growth charts within the RCPCH, but there's so many others that could be done. We just haven't had the time, and the funding really to do it at the RCPCH yet, but it is on our kind of roadmap. But where's everybody else? Surely every other college has its clinical calculations that they use all the time that would be great to be able to get hold of. I picked an example of BMI being easy, BMI centile not quite so easy, because you've got to have this reference charts and things like that. So, and then you've got to be able to do all of that, clinically assure the answers, make sure it's up to date. Or you could use an API. Now in 2015 that probably worked. Now you need to go to growth.rcpch.ac.uk, which is where we've done exactly that. So back in 2015, when I first did these slides, this didn't exist, but now we have digital growth charts as a service. So what I'd really like to see is more of these kind of things being commoditized and put out as a service. And there are many other things that you might want to do as a service. For example, semantically aware cloud storage. So, that could break the deadlock between data and the applications that would allow us to separate them. Clinical decision support. There's so many other things. It's fundamental to understand the role of APIs and how that has enabled the tech world to go so fast and so far so quickly. We're lagging behind because of a very straightforward reason. We haven't bothered in the healthcare world to build these APIs. If we did build these things, these infrastructural components, then progress would be faster. We would have a better market of new systems coming along, because they would be able to focus on the bit that differentiated themselves from other systems, the user interface and the ease of use and the usability, because all the difficult technical stuff would be something they could get as a commodity service. So whether it was EPS or clinical calculations or the storage side of things, or scheduling or messaging to patients, whatever it is, all of those things need to be APIs that you can just purchase. And that drastically reduces the amount of work that's required for a new app to be built. I'll just conclude with a little bit of a different presentation that just talks about APIs being the public utility infrastructure of the web, and by extension, all of health tech doesn't have these things. So you've got to have railroad tracks before you can build a train. You've got to have reliable mains electricity before you can build a fridge that you can just sell everywhere. Without the satellites, you can't make a sat nav. You can't start writing mobile apps until there's a platform to put them on. So these public utilities of the web, essentially APIs, enable innovation. And it's one of the clearest areas for me that explains why people talk about digital transformation and it doesn't happen. People talk about innovation and it doesn't happen. People talk about all kinds of things that they can imagine being better in healthcare tech. But until we've started to commoditize and turn some of these things, some of the underlying technologies, into much simpler public utility type things, we won't get the innovation on top, because building the innovation still requires you to build all of the difficult stuff underneath it. So it just makes the cost really extraordinarily high. It also means that existing suppliers have much more of a stranglehold. So any existing secondary care or primary care record systems can add a feature with a relatively small amount of additional work. But for somebody else to go into competition with them, they've got to build the entire stack from scratch, and there's nobody out there helping them, making any of it easier. So you've got to start from absolute zero. That just means we are and we will be stuck with the current incumbents for a very long time, until something changes, until somebody makes a new system. We're talking about infrastructural problems, and I think that's where APIs help you to break those infrastructural problems down into smaller components on top of which people will innovate. So I'm going to leave it there. This is a kind of short, sort of general chat, educational one. If you want me to go into more technical detail about APIs, what they are and how to use them, for example, some actual code examples of like what it's like to send an API request and get a response back, I'm absolutely happy to do that. Just let me know in the comments, and obviously if there are any other topics you want me to cover, then again, let me know in the comments what you would like to see on this channel. Over the course of 2026, I'm hoping to do at least one big sort of interview a month. So that's the plan. So I'm going to talk to some of the founding fathers, as it were, of the GPIT world, partly because some of these people are now retired, and we risk kind of losing some of that first-hand account of how it was all done. How did GP clinical systems come into being, how they got built, all that kind of stuff. So I want to capture some of that. It's just nice to have these chats as well, and I always learn something from the people that I interview. So there will be interviews, there will be sort of more technical stuff, and there'll be the stuff in between, which is like this, which is kind of like explaining a technical topic, like what is an application programming interface and why it's important, but without going into technical detail. Anyway, I hope you're enjoying the channel. I've been enjoying making it, and it's been really nice to get some of this stuff off my chest, if I'm honest, some of the stuff I want to say. And I look forward to going into the zone of uncomfortable debate with you in 2026.